So we want to find some vector projections. And we have two things that we're asking us to find. For these pairs of u and v, we want to find the projection of u onto v, and we want to find the vector component of u that's orthogonal to v. So if you recall, I have a vector u, and then I have a vector v, that I can separate that into two pieces, and we'll call them A and B. Where A is the projection of u onto v, and B is that orthogonal component. So I want to write it like this because if you think about it, if u is A plus B, then if I want just the vector component of u that's orthogonal, if I want to isolate that, well, then I can subtract the vector projection. So if we find the projection, we can subtract it from the original vector to get the orthogonal component. That's the pretty standard way to get it. All right, so let's get to solving. So I guess I'll go ahead and write. Remember that the projection of u onto v I know this can feel backwards because you write the v before you write the u. Well, let's not get into it, but it's u dot u over v dot v times v. Okay. So in this case, I'm going to write that vector A, which is just a projection vector. I'm simplifying that as u dot u v dot v times v. So in this case, that's 2 times 3, so 6, plus negative 3 times 2, plus negative 6 over, well, in this case, v dot v is 9 plus 4. But what we find here is that's just 0. So the projection is actually the 0 vector. So you think to yourself, well, wait a minute, the projection's the 0 vector. Well, yeah, that makes sense because I have a vector. Let's draw this out. I have a vector I have 2i minus 3j, so that's here. And I have 3i plus 2j, and that's here. So this is u, and that's v. Well, they're already orthogonal. So if they're already orthogonal, then there is no vector to project onto u. There's no vector in that direction. So if A is the 0 vector, then the orthogonal component is the u vector. So in this case, there's your answer. So let's go and let's do the second one. So we want to get u dot u which is 16 plus 2, or sorry, u dot, this was u dot v. Man. It's not u dot u. This is u dot v. Man, I'm just all over the place here. I apologize. That's my big mistake. If I'd done u dot u for this, it would have been terrible. All right. U dot v. U dot v. So 8 times 2, 2 times 1, and 0 times negative 1. So that's 0 over v dot v. So 4 plus 1 plus 1. And again, that's multiplied by v. So that's going to be 18 over 6v, which is 3v. So 3 times v is 6, 3, negative 3. So that is the projection of u onto v, and that orthogonal component is u minus that. So that's going to be 2, negative 1, and positive 3. So you might ask yourself, well, how do I know if I did this right? Well, the projection of u onto v will always be a scalar multiple of v, right? So this is 3 times v, so we feel good about that, right? It's definitionally what we did. And then we might say, well, how do I know that this is the right answer? Well, since this thing is orthogonal, b is orthogonal to v, then this vector will be orthogonal to this one. So that will be 4 minus 1 minus 3 is 0, right? So therefore, we can feel like we've done that right. There is one extra piece you want to do. We have a parallel component. We have an orthogonal component. To make sure you did it exactly right, you should probably, well, you should add these two to get that, and you should go ahead and take the magnitude of these vectors or the sum of the vectors and make sure it's the same. There's a lot of extra steps you can do, but just know that there are a lot of ways to check your answer if that's what you're interested in doing. And so finally, let's do this one. So the projection of u onto v is negative 1 times 5, so that's negative 5. 5 times negative 1 is also negative 5. And 8 times negative 1 is negative 8. And again, that's over v dot v, so that was u dot v. Now let's divide it by v dot v, which is 1 plus 25 plus 64, all multiplied by v. That gets us negative 18 over, what is that, 90? Times v, which is negative 1/5 v. So that tells me that my projection vector is negative 1/5 I plus j plus 8/5 k. And so to get that orthogonal component, I subtract that from u. So subtracting this from u will get me 26/5 I minus 2j minus 13/5 k. And those are your answers. It's going to take some practice to get projections right. It's mostly just a lot of algebra and a little bit of memorizing the formula, which I clearly didn't do.